generation assembly. Since last 2 to 3 days, I'm just talking about LMS, right? So for some of the students, I already gave an orientation. So those who do not know about the LMS, so let me just guide you how the LMS is going to work like, right? Okay, let's just spend some time on our LMS and then we are going to start our session. Okay, so for the new students and already students who are recruited, okay, in our courses, basically we are transitioning them to our LMS, right? So LMS is basically a proper learning management system. So this is going to be the dashboard which guys are going to have. You guys are going to be having your login details, right? You have to log in into the next generation USMLE LMS. There you guys are going to be having live classes options. You have to click on that. There the link is going to be shared and you have to click on the link. The classes are going to be taken there, right? Next, the entire course roadmap is going to be uploaded there in the course section. Is it clear? And apart from that, the recorded sessions are also going to be here in the library, right? So all of the recorded sessions are going to be there, well organized, okay? And the assessment which we basically take are also going to be within the LMS, right? We have also integrated this attendance option in order to keep track of our students. So you guys are going to be having your proper attendance, and those who miss 3 consistent sessions without having a proper genuine reason, so you guys are going to be answerable for that, because it's really hard to keep an eye on every student in these WhatsApp groups. So that's why we are transitioning to this LMS. It will just take 1 week for you guys. You guys have already sent me your credentials. I'm uploading your details into the LMS. So here, all of the students which are in the course are going to be viewed here. You can message your mentor. So we have Omar. Omar is going to be there helping you. Soon I'm going to introduce him in the groups. You can just share your details, and whatever problem you have, you can just be there. Okay, he's going to be available every time for you guys. Okay, apart from that, the assessments are going to be taken here, and all of the courses are going to be here in the LMS. So if it's a basic overview of our LMS, we are going to be having a detailed webinar again on that once it's made, and once each and every student information is feed it into our LMS, right? So let's start our session again. Okay, the recording is started. So we were discussing, we have our central nervous system and we have our peripheral nervous system, right? The central nervous system basically comprises of your brain and spinal cord. Okay, okay. And why do we call it central nervous system? Because it's present centrally. What is peripheral nervous system? Peripheral nervous system is basically the communication between your central nervous system and out there your organs, right? So for example, if this is your central nervous system, and not okay, so this is your brain and this is your spinal cord, right? Okay. So for example, to get information into the central nervous system, because the main goal of information is to get into the central nervous system, right? We have certain nerves, right? For example, let's just take an example of your hand, right? Hand muscles. So we have peripheral nervous system, which would help take information from your peripheries into your central nervous system. So it's a kind of relay present between your central nervous system and outside any of your muscles, your skin, and everything, right? So we have peripheral nervous system. Peripheral nervous system can furtherly be divided into 2 groups, okay, or 2 classification. Why? Because the sensations which are coming into your central nervous system, they can be sensory. We know that the sensory can be entering into your central nervous system, and in order to process that, which we'll be discussing in detail, how do we process sensory information, basically your central nervous system is going to send a motor response as well through this peripheral nervous system, right? So peripheral nervous system can be divided into 2 subcategories. And what are they? Sensory and motor. So the sensory information are the one which are coming from these organs, entering into your central nervous system, spinal cord, entering into the brain, and the brain is basically going to compare that information with some previous information, with some previous experiences, and then your brain is going to launch a response. That's going to be a motor response. Let me just give you an example. For example, if your hand is on a hot, let's suppose any medium which is really hot, right? So this heat, increased heat can just cause damage to your skin. Your sensory peripheral nervous system is going to take all of this information into your central nervous system. Central nervous system in the brain is going to compare it. Yes, it's really heat. with the previous experiences, and the previous experiences of your brain would initiate a motor response telling your hand to just move away, contract the muscles, move away, because it's heat, it can damage. So this is the entire process of peripheral nervous system, bringing your sensory information into your central nervous system, comparing it with the past experiences, and generating a motor response. Is it clear? Hello? Hello? Any problem till now? Any?
Hello.
Yes, please. Hello? Okay, so what's the function of central nervous system? As I just already told you, central nervous system is going to get sensory information, and it's going to compare that information with some previous, or previous data, right? And after comparing it with that data, your central nervous system is going to take a decision. What shall I do now? Okay, based on the past experiences, right? And based on that, what happens that it is going to generate a motor response, and motor response is going to come from the central nervous system, again through peripheral nervous system into the peripheries group of muscles and everything. Okay, so this was all about your central and peripheral nervous system. Peripheral nervous system, further the sensations can be some special sensations, it can be some general sensation, right? So the peripheral nervous system sensory part is going to be divided further into two groups, that is special sensation and some general sensation. What are special sensations? Special sensations are those which are really special. For example, vision, for example, olfaction, taste, hearing, equilibrium, position. That's all your special sensations, right? So they are basically coming from a specific part of your body. Like vision can only be perceived by your eyes. No one else can do that. Olfaction can always be perceived by your nose, nasal epithelium. No one else can do that. Taste by your tongue. No one. So these are some special parts which bring special sensations into your central nervous system. And we have some generalized sensation, which you already know what are generalized. They are general for many parts of your body. For example, touch sensation can be on both of your hands, on your feet, on your abdomen, everywhere. These are general sensations, right? Okay. The general sensations further can be divided into two groups. That are your somatic and your visceral. So what are your somatic sensations? They basically come from the superficial part of your body, right? For example, your skin, right? The locomotive system, muscles, joints, right? Okay, and the types are pain, temperature, proprioception. They can just come from there, right? We'll be discussing seeing what proprioception is. Then we have our visceral sensation. We know that the visceral sensations basically comes from the viscera, visceral organs. And any kind of pain in the visceral organ is a dull pain. You guys know that, right? It's the nature of your visceral sensation, right? The distension, for example. Okay, what is proprioception? Do you guys have any idea what is proprioception? We'll be discussing it in multiple places once we are doing our.
Sense of the movements and the position.
Perfect. So in order to make it simple, proprioception is, let me just make it a really simple definition. Without being knowing position of your body, that's proprioception, right? Without being thinking. Like for example, if I just close my eyes, you guys can just close your eyes with me. You know, we know this is our right hand, one finger, two finger, three finger. Without looking towards it, subconsciously, I know the position of each and every parts of my body. For example, while closing your eyes, I'm just telling you that put the right side hand, thumb finger on your nose. You can easily do that. You aren't seeing, still you can do that. Why? Because it's ingrained subconsciously in your brain. You already know different parts of your body without seeing them, right? So that is basically proprioception. Is it clear?
Yes.
Hello? Subconsciously knowing different parts and orientation of your body, that's your proprioception. That's simple, right? Okay, so remember, for example, in the central nervous system, we are having the cortex, and we are then having the brain stem, that is the midbrain, pons, and medulla, right? Okay. Remember, in the cortex, once sensations enter into the cortex, that's going to be a conscious level, right? And below the cortex, if any information is entering, that's going to be your subconscious, conscious mind, or subconscious brain. Okay, like for example, if someone just hit me on my face, right? So that's going to enter into my conscious brain. I'm going to start thinking on that, right? But yeah, see if just hit me, what shall I do? I'll just compare it with the previous responses. But for example, whenever I'm walking, I don't think about walking. I do that subconsciously. I do that subconsciously, right? The proprioception itself enter into your subconscious brain. So your subconscious brain, without thinking, it have that information. So you have conscious brain and subconscious brain. Conscious brain lies at the level of your cortex, and subconscious brain lies below the level of your cortex. Is it clear? Okay. So the motor peripheral nervous system, right? So we discussed the sensory, sensory. We discussed the sensory it can be special senses, it can be general sensations. The general can be somatic, it can be visceral. Let's discuss about the motor. The motor can be somatic motor or autonomic motor responses, right? The motor can be somatic motor responses, or there can be autonomic motor responses. What do we mean by somatic motor responses? Like the sensations that are under voluntary control, they are your somatic motor responses. For example, if I'm just telling you to run, you can just simply run. If I'm just telling you to stop running, you can simply stop the running, right? Okay, so that's basically the voluntary control of your body, moving parts, right? Moving parts, because it's a motor response. Then you have autonomic response. For example, if you just saw any beast, right, or any monster, your heart would just start beating a lot. Your heart would just start beating a lot. Your glands are going to do a lot of secretion. So that's not under a voluntary response. If I'm just telling you to just stop, you know, stop contracting your heart too fast, can you do that? Hello?
No, no,
No,
no.
we
It's
do
it's
that.
not under our control.
Yes, it's not our control. So that's basically autonomic motor response, right? Autonomic and somatic. So hope so you guys know the difference now, right? Okay, so this was all about the general distribution of the general things which we'll be discussing again and again. Then we have our nerves and glial cells. What are your neurons or nerves? What are nerves? Nerves are basically your neurons, right? Made up of neurons. What are neurons? Do you guys have any idea? Hello? No
It's
responses. What are
functional.
your...
It's good
Okay,
Yes,
information.
sir.
perfect. So neurons are basically the functional part of your central nervous system. They are the functional part of your central nervous systems are your neurons, right? And what do you mean
Mhm.
by the functional part? What is the function of your nervous system? The function is basically, I just told you, that's your conducting your electrical impulses, right? So neurons further
Mhm.
can be divided into cell body and axons, right? Cell body and axons. So those are basically your neurons. Neurons are the functional part of your central nervous system, right? They can generate action potential, conduct electrical impulses into your body. Then we have our glial cells. What are glial cells? Glial cells are basically the supporting cells of your neurons. So these glial cells support your neurons, right? They're going to support your neurons. Okay. Remember, this cell body of your neuron is basically going to appear gray in color, right? Cell bodies always appear gray in color. Keep that in mind, right? I'm going to tell you a deep concept after that. Axon, we know it's myelinated, right? We have a myelin sheath which is going to surround the axons. We know that we'll be discussing that the myelination can be done by two types of cells. Do you guys know that? Schwann cells and your oligodendrocyte, right? Hello?
Yes, sir.
Okay.
Yes, yes.
But we know that the neurons can be peripheral nervous system or in the central nervous system. So the neurons which are present in the peripheral nervous systems are going to be myelinated by your Schwann cell.
Yes, yes.
The neurons which are present within the central nervous systems are going to be myelinated by oligodendrocytes. Schwann cells can only myelinate, a single Schwann cell can myelinate single portion of your neuron, while a single oligodendrocyte can myelinate multiple axons of the neurons, right? If there is a demyelinating disease which is going to affect your Schwann cells, that would be Guillain-Barré syndrome, which we'll be discussing in detail. If there is any kind of demyelinating, removing the myelin sheath is a demyelinating disease of your oligodendrocyte, that would be multiple sclerosis, which we will be discussing in detail. So due to this myelin sheath, axons are going to appear white once you visualize that. Is it clear? So for example, let me just, let me just test your concept now, right? For example, if I have a collection of axons, right? For example, I know, okay, axons basically carries information into the cell body. Keep that in mind, right? And cell body is gray. Keep that in mind. So in the spinal cord, basically we have, collection of axons which are going to move upward into the brain in order to get information into the brain. As I already told you, for example, if it's your brain, your spinal cord, you're going to get information. That information is going to be taken into the brain. Who takes this information? That information is taken by these collection of axons. Am I right? Because axons carry information to your brain. Am I right?
Yes.
Okay.
Yes.
So if I just visualize them, won't they be white in color due to myelin sheath? Hello? They're
Yes.
myelinated axons are. So can I say that the
Yes.
white matter within the spinal cord are basically the collection of axons. They are bundle of axons. Why are they white? Because they appear white due to myelin sheath. Can I say that?
Yes.
Yes.
Perfect. All of these axons are going to give information to the cell bodies. Cell bodies appear brown in color, right? So we know that, for example, if this, let me just draw the cross section of spinal cord, right? So the spinal cord, basically you have a beautiful butterfly sitting here in the bed, right? Okay. And we have all of the butterfly appear gray in color. All of these places, the dorsal column, the lateral column, anterior, are white in color. So can I say that here in the white column, why do it appear white? Because it have bundle
Myelin.
of
Myelin.
axons,
Exxon.
axons which are myelinated. That's why they appear white. Why do they appear gray in color? The beautiful centrally placed butterfly, because they have collection of cell bodies.
Bodies.
That's why they appear gray in color. Can I say that?
Yes.
Oh, perfect. Remember, whenever whenever the cell bodies are present within the central nervous system, as a bunch, a lot of gray matter and deep, they're called as nucleuses,
Nicholas. Okay.
right? Whenever a group of gray matter are present deep within your central nervous system, they are called as nucleuses. When the same gray, okay, what are gray matter? They are basically your cell bodies. Do you know that? Okay, don't forget to remember that. Okay, so these are basically cell bodies. Whenever they are present within the central nervous system, they would be called as nucleuses. When the same collection of your your cell bodies are present outside the central nervous system, they would be called as ganglion. Is it clear? Hello.
Yes.
Hello. Ganglion, whenever the gray matter is present outside, whenever the gray matter is present inside, they are called as nucleuses. Is it clear? And nucleuses are basically your cell bodies. Am I right? Hello.
Yes.
Yes,
Okay.
you're right.
So let's discuss our next topic, which are basically about white matters, right? So the white matter, we know what is white matter. White matter is basically collection of axons.
Nicholas.
Why do they appear white? They appear white because they are myelinated. They have myelin sheath on the surface of it. That's why they're called white matter, right? So the white matter can be furtherly divided into, tracts, which we'll be discussing, commissures, which we'll be discussing, and association fibers, which we'll be discussing. These are some general terminologies. You might have heard tracks before. You might have heard the terminology commissures before. You might have heard association fibers before. Let me just tell you what are they. All of them are basically your white matter, right? All of them are white matter. All of them are basically your collection of axons. All of them are collection of axons. But the tracks are the collection of axons or the white matter, which basically carries information caudal to the central nervous system. So, for example, if this is our central nervous system, the tracks are going to take information into the central nervous system, right? Into the central and away from the central nervous system. So, upward and downward, the information is going to be taken by your tracks. Is it clear? Okay. Okay, can you just please give me a second, please? Hello? Okay, so tracks are basically the white matter. They are collection of axons which are either moving up or coming down, up, down, taking information into the central nervous system or bringing information from the central nervous system down and connecting your peripheral. So they are going to be called as tracks. Whenever the white matters are moving up or either moving down, they are tracks, right? What are commissures? Yes. Any idea?
Is how the right side and the left side communicate.
Perfect. So these are same white matters or they are same, group of axons which basically communicate the right side to the left side. Like for example, let's just take example of the same picture, right? So we discuss, okay, now the concept is going to be really clear. I just told you these are your white matter, right? They are, they are dorsal column white matter in which your axons are basically running. They're again white matter. Here you guys can see it's also white matter, right? Hello?
Yes.
But for example, if this is your, okay, so this, let me just draw a proper picture of your spinal cord cross section. So you can see this part of your white matter are basically connecting the right side to the left side. So can I call this part as anterior commissure? Hello, because commissure are those white matters which connects right side to the left side. Can I say that?
Yes.
Okay, let me just give you another example. You have your brain, right? You know that you have the right hemisphere and the left. Right and left hemisphere are basically connected with one another, right and left, called as corpus callosum, right? Corpus callosum. So can I say that this corpus callosum is a big commissure? Why is it a
Yeah.
commissure? Because it's basically connecting the right side of your brain to the left side of your brain. So whenever in the central nervous system, we have group of white matter which are connecting one side to another side, they are going to be called as what? They are going to be called as
Commercials.
perfect. Then we have our last one, that is association fibers. What are association fibers? Association fibers are same, white matters, but they connect, central nervous system anterior posterior, anterior posterior, right? Okay. So we are going to discuss association fiber in brainstem, the specific names and everything. But till now, you should keep in mind that the white matter or the bunch of axons which connect your central nervous system anterior posterior. Is it clear?
Mm-hmm.
Okay. So this was all about height. Let's discuss okay, the next topic should be the difference between tracts and the difference between nerves. Okay, let's discuss what is the difference between tracts and nerves. Nerves and tracts are not same thing. Keep that in mind, right? We discussed what are tracts. Who is going to be telling me what are tracts? We already discussed.
These are group of
While
axons which
from
up.
traveling up and down.
Go up and down.
Okay, these are a group of axons which basically runs
Caudal
superiorly and
tunnel.
inferiorly in the central nervous system, taking information to the to the brain, bringing information from the brain into the spinal cord, bringing it peripherally. Okay, we know that who myelinates your tracts, which
Swans.
cells myelinate.
Myelin sheath.
Swans.
Myelin sheath.
Swans have
Oligodendrocytes.
And spinal
Oligodendrocytes.
cord is
dendrites.
Schwann cell and oligodendrites in the CNS.
Okay, so oligodendrocyte basically myelinates your tracts because tracts are all only present in the central nervous system. Nerves are basically present outside the central nervous system. They basically communicate. They are basically component of your peripheral nervous system, right? So we discussed that oligodendrocyte would myelinate your tracts, while the Schwann cells, we discussed, while the Schwann cells myelinates your peripheral nerves. Peripheral nerves are myelinated by the Schwann cells, right? Okay, so this is going to be one of the difference between central nervous system and peripheral nervous system. Let's discuss what are receptors. Receptors. Okay, as we discussed, for example, we have an individual. He put up his hand on fire. Let's suppose, right? So the fire is going to give heat to his hand, right? Okay. So how does he perceive heat? Because heat cannot itself travel into the nerves, right? Only the electrical impulses can travel in the nerves, right? So basically, this heat energy is going to be transformed into electrical energy, and that electrical energy is going to be, moving in your nervous system. Does that make sense? It means we must be having something that can transform one form of energy into other form of energy. Am I right?
Yes.
Okay. And this something which transform one form of energy into other form of energy is called, they're called as receptors. With this, so receptors or transducer, there are certain apparatuses which transform energy, one form of energy, that is any kind, if it's heat energy, if it's a chemical energy, into electrical energy, because only this electrical energy can travel in our nervous system, in the peripheral nervous system. It can be brought into the central nervous system. It can be brought to your brain, and it can be compared with the past experiences in order to generate a motor response, right? Okay, so how do it come into your brain? Okay, so first of all, we discussed that peripheral nervous systems are going to take all of the information into the spinal cord, right? In the spinal cord, we discussed we have this beautiful butterfly. Okay, okay, so you can see we have these posterior horns and we have anterior horns. Am I right? Hello?
Yes, sir.
Yes.
Remember, posterior horn, they are purely sensory in nature. What do I mean by sensory in nature? All of the sensory impulses, the sensory responses from your peripheral body are going to be, first of all, entering into the posterior horn. As they are gray matter, they are having neurons, cell bodies. So the cell bodies of neurons which carry on or which bring sensory information from different parts of your bodies are going to be present in the posterior horn. Is it clear? Hello?
Yes.
Okay, so posterior horn is going to carry all of the sensory information, okay, from your peripheral body. Anterior horn, we discuss as this sensory information come, either, okay, these are the cell bodies. Cell bodies would, start giving off their axons. Either these axons can enter into the dorsal column, either they can enter into the lateral column, right, which we'll be discussing in detail, right? So then they're going to move upward into the brain, and the brain is going to launch a motor response. So the motor response is going to be coming through the tracts, descending tracts, motor tracts, right? They're going to be coming here, and the cell bodies of these motor responses are going to be present in the anterior horn of spinal cord. So can I say that the anterior horn of spinal cord made up of gray matter having only the cell bodies are going to be pure motor in nature?
Yes.
Okay, they are
Yes,
going
sir.
to be purely motor in nature, and once they are then going to give their fibers onto the muscles in order to undergo a proper response, right? So we discussed our spinal cord. We discussed spinal cord have that gray matter, white matter. White matter have those a collection of tracks moving upward, moving downward. We have a beautiful gray butterfly. It's a gray because we have cell bodies there. We have two horns, posterior horns, which have gray matter cell bodies of the sensory nerves, bringing sensory information, taking into the brain. Once the brain launches a response, it's going to generate a motor response coming downward. A motor response, gray matter, anterior horns are only going to be having cell bodies of motor nerves. Is it clear? Hello?
Yes.
Yes.
Yes. Great.
Okay, perfect. So we discussed the white matter have different column. This is going to be the dorsal column. This is going to be the anterior portion. And this is going to be the lateral portion. Is it clear? Hello? Hello? Okay. Remember one thing. Now we are going to discuss tracts. Next topic for today's discussion is going to be tracts, right? And we are going to discuss two tracts: the dorsal column tracts and anterior lateral column tracts. Okay. So this is basically the dorsal column, and this is the anterior and the lateral column tracts, right? So first of all, let's discuss the dorsal column. Remember, the dorsal column tracts are basically really modern in nature. They're really modern, right? So tracts are basically the pathways. I can just take this concept through which the impulses are going to move. They are basically roads, okay? Roads or pathways. So the roads or pathways of the dorsal column are really modern in nature, right? They are modern roads. So modern roads, nowadays the roads are really smooth, right? If cars are going on those roads, they are going to move with high velocity, right? Right? And anterolateral are going to be really primitive in nature. So the rods or the tracks, which are the component of your anterolateral column, are going to carry impulses with a really slow speed because they are old rods, they are primitive rods, right? And as they are modern rods carrying modern sensations, like those sensations which were evolved through the time period. Like maybe if you just go into your ancestor, maybe they won't had these sensations. They evolved with time. They are modern sensations, right? So the dorsal column is going to be having modern rods carrying modern sensations. Anterior lateral columns are going to be having primitive rods carrying primitive sensation. Primitive sensations are those sensations which were present in our primitive, ancestors, and which sensations were important for the for our primitive ancestors. Those sensations which were important for survival only, right? So which sensations are important for survival? Temperature at that time was really important, and pain was really important. So both temperature and pain are primitive sensation. The crude touch was really important for the survival, right? In order to know the consistency of different things, if it's hard, if it's light, if it's soft. So these three sensations are primitive sensations. They were present in our ancestors in order to promote only survival. But with time, individuals, once they were modernizing, they get some modern sensations. For example, fine touch, right? Fine touch basically wasn't important for your survival at that time, but it evolved some specialized sensation. Proprioception, proprioception. It evolved with time. It came with time. It's a modern sensation. Vibration, because you can just simply imagine why would our primary ancestors, what would they do with vibration? They didn't had phones, which could vibrate, right? So they didn't have vibration sensation. It comes with time. They are modern sensations. 2 points. discrimination, how to discriminate between 2 points. If I have a hand, I just pinch a needle here and a needle, and even though closing your eyes, you can differentiate these 2 points. That wasn't important for your primitive ancestors. It evolved. It's a modern sensation moving through a modern rod. Modern rod is your dorsal column. Is it clear? So the dorsal have modern sensations, anterior lateral have primitive sensation. Modern sensation have to move through a high velocity proper rods. So it means they are highly myelinated. Highly myelinated.
Myelinated.
Because the myelin sheath is really important for the impulses to move with a higher velocity inside your nerves, right? So that's why they're highly myelinated, right? And the primitive sensations, they are really less myelinated. So the velocity of the sensation in those tracks are going to be really slow. Is it clear?
Mm-hmm.
Okay. So let's discuss dorsal column in detail, right? The sensations being coming to the dorsal column. So first of all, let me just make a spinal cord, right? For example, if this is your spinal cord and these are different cross sections of your spinal cord, right? So you can see, like I'm just drawing the spinal cord, the beautiful butterfly coming like that, spinal cord, okay. 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 So we are discussing dorsal column. So it's going to be sensory in nature. Am I right?
Yes.
And which sensations are going to be coming? Modern sensation. What are your modern sensation? Fine touch,
What is fine touch?
proprioception, 2 point discrimination, specialized sensation, vibration, right? So once these
Yes.
sensations just come from different parts of your bodies, now you guys are going to be telling me they are sensations. Would they enter into the dorsal column, or the dorsal horn, or the anterior horn, or the posterior horn?
Posterior on.
So they are going to enter here into the posterior horn. And then what happens? They are going to directly move into the dorsal column, right? Just like that. Jump into the dorsal column. Am I right?
Mm-hmm.
Hello?
Yes, sir.
Okay, for example, if these sensations are from the hand, and let's suppose these sensations are from the legs. From the legs, the same sensations. Coming just like that into the dorsal column, jumping into the here, right? Okay, so they're going to be moving just like that, moving upward in the dorsal column, right? Okay, so these are the sensations coming like that, again, moving upward like that, right? So as you guys have, did you guys notice something? The sensations which are coming from the legs are more medial in this dorsal column, right? And as we are moving upward, like here the sensation of the lower leg, and it's going to be more laterally. So can I say that the sensations, the modern sensations which are coming from your lower part are going to be more
Media.
medially in the dorsal column, right? And the sensations which are basically coming from the upper body parts, upper body,
More
are going to
lateral.
be distributed more laterally, right? So you have a UWorld MCQ on that. They are going to be telling you we have legion in the dorsal column more medially. If you have a legion here, modern sensations are going to be lost in the hands or in the legs. What do you guys think? Yes,
Next.
from the legs. Perfect. From the legs, right? Okay. So as these sensations come down, they just move to the posterior horn, moving in the dorsal column. So then they are going to move in a form of bundles, right? So they are going to be moving in a form of wires, like spherical wires, right? Just like that. Am I right? Hello? They're going to be moving in a form of bundle because we do not have a single neuron. We have a bunch of neurons here, right? So these bundle form of fibers which are moving in the dorsal column are going to be called as fasciculi. So what do we mean by fasciculi? Whenever we have bunch of axons moving in a form of spherical shape, like spherical wires. Wires are spherical in nature, right? So these spherical shape wires are basically called as fasciculus. Okay. Okay. What is lemniscus? Lemniscus are same, same fibers in a form of bundle, but moving in the form of like inflated kind of, right, wires. like that, not spherical properly, right? So whenever okay, there's some disturbance in mic. Can you just please fix that? So we have two terminologies: fasciculus and lemniscus. Fasciculus is basically spherical form of the bundles of axons moving up or down in a spherical shape. So once it attain a spherical shape, we are going to call it as fasciculus, right? And once it attained an inflated kind of shape, we call it as lemniscus. Okay, keep this terminology in your mind. So as these nerves are coming down from the legs, they are moving upward, but as we just look to the shape of this collection of bundles, they are going to be spherical. So let's just call them fasciculus. Am I right? Yes or no? Because they are spherical in the shape, and wherever we are having spherical shape bundles of axons, we call them fasciculus. Am I right? Is it cleared? Any problem?
Yes, yeah.
Okay. So as these fasciculus just comes from the legs, so remember legs are really graceful, right? What do I mean by graceful? We are going to call it as fasciculus gracilis, right? Coming from the legs, bringing these modern sensations, directed more medially in the dorsal column, called as fasciculus gracilis. Is it clear? Hello? And the sensations, the same modern sensations coming from the upper parts of your bodies, directed more laterally in the dorsal column, moving again in the shape of spherical. Okay, it's not spherical, it's cylindrical. Again and again, I'm saying spherical. Sphere is a round thing, right? Okay. Moving in the form of cylindrical, form of bundles, again, they are going to be called as fasciculus, but since they're coming from the upper body, they are going to be called as fasciculus cuneatus, right? Is it clear? Fasciculus cuneatus. Is it clear? Do you guys have any questions till now? Please ask me.
Sir, can you please repeat it in short, just for review?
Okay. Okay. Sure. We have our modern sensations. Modern sensations moves in the dorsal column. What are your modern sensations? 2 points discrimination and proprioception. Can you please fix your mics? There is some problem, Doctor. Okay, thank you. Okay, so once these sensations are coming from the lower body, from the legs, they're going to enter the dorsal horn because it's sensory in nature. They're going to get into the dorsal column more medially as we are moving upward. So the same modern sensations are going to be more laterally in this dorsal column, right? So if we have a lesion
Yes, sir.
laterally, so these modern sensation of upper body is going to be gone. If we have lesions more medially, so the sensation, these modern sensation of your lower legs are going to be gone. Is it clear?
Yes.
Okay, perfect. So they're moving in the form of cylindrical bundles. Whenever we have cylindrical bundle distribution of axons, they're called as fasciculus, right? So the sensations coming from the lower legs are called as fasciculus gracilis. Sensations, the same modern sensation, touch, proprioception, vibration, everything, right? These sensations coming from the upper body, arms or upper bodies are going to be called as fasciculus cuneatus. Is it clear?
Right, sir.
Okay. So they are going to be moving upward, and once they reach the medulla, so we know that we have pons, we have medulla, right? So the pons and we have medulla. In the lower medulla, okay, these are first order neuron, like a single neuron coming, bringing information here, directly jumping here, axons moving here, right, into the medulla. In the medulla, we are going to be having second order neuron cell bodies there, right? And they're going to synapse on the second order neuron. Okay. So all of the gracilis fibers are going to synapse on, okay, in the central nervous system, bundle of gray matter are called as, yes, we discussed, nucleus, right?
Yes.
They are gray
Nucleus.
matters,
Yes.
they are gray matter, they are cell bodies present in the central nervous system. That's why we call them as nucleus. If they are cell bodies, gray matter present outside the central, we call them ganglions, right? Is it clear?
Yes, sir.
Okay, perfect, right? So we have gray matter. Okay, we have these ganglion. They are going to synapse on the. They are going to synapse on these nucleuses. The graciles are going to synapse on nucleus gracilis. So these medial two nucleuses are going to be called as nucleus gracilis, right? And the fasciculus cuneatus, which were basically the modern sensation from your upper arm, are going to synapse on these nucleuses called as nucleus. Yes, nucleus cuneatus, right?
Yes.
Cuneatus. So the medial two gray matter are called as nucleus gracilis. The lateral two are called as nucleus cuneatus, right?
Mediator.
Okay. So once there is first order neuron synapses on them, what would happen? They are going to decassate. The right sided are going to move towards the left side. The left side are going to move towards the right side. And again, they would start moving upward, right? Is it clear? Once they decassate on these nucleuses, they are going, once they synapse on the second order neurons, the nucleus of second order neuron, they are going to decassate. The right side are going to move leftward, the left are going to move rightward. Then they are going to start moving upward. These decassation at this level, they are basically called as internal arcuate fibers, right? These fibers are internal arcuate, okay, fibers, okay, or arcuate fibers. Simply, you can just call them as arcuate fibers, right? Okay. So remember, once after decassation, they started moving upward. Now they won't be moving in a form of cylindrical distribution. Now they are going to moving in this like inflated kind of fibers. So now can I call them lemniscus?
Yes.
So now
Yes, sir.
after decassation, they are going to be moving in this inflated form of wires, and we are going to call them lemniscus, right? And this lemniscus is going to move upward into the thalamus. In the thalamus, we have a nucleus called VPL. They're going to synapse there on the VPL nucleuses. Okay, so the third order neuron is going to start. Third order neurons are going to move upward. So we have internal capsule, which we'll be discussing in detail. Through the posterior limb of internal capsule, they are going to move into the somatosensory area of your brain, which we are also going to discuss. Is it clear? This pathway is also called as dorsal column medial lemniscus, and it makes sense. Why do it call it a dorsal column? Because it moves in the dorsal column. Medial lemniscus, because as they decassate, they are going to move in a form of lemniscus. Why do we call it medial? Because in the brain stem, this lemniscus move medial in the brain stem, medial in the medial portion of the brain stem. So let's call it as dorsal column medial lemniscus system, which carries modern sensations in the dorsal column. Does that make sense? Yes or no?
Right, sir.
Yes.
Okay. Okay. So, okay. So as let's discuss what is VPL. You're going to be hearing this VPL of the thalamus a lot. Let's just break it down and let's just discuss what is VPL. It's a little bit, we are going to do it in our thalamus module in detail, but let's just discuss it. Okay. This is your thalamus, right? I'm just drawing your thalamus. Okay. We have a beautiful Y in between. So the thalamus basically get all of the sensory information except that of your taste, sensation, and olfaction. Each and every sensory information come into the thalamus. Thalamus is basically divided into three portions. You can see anterior portion of the thalamus, the lateral portion of the thalamus, and the
Posterior.
medial portion. Medial, lateral, anterior. Medial, lateral, anterior. Is it clear? Hello?
Yes.
Right, sir.
Okay. Okay. So this lateral portion is further divided into two parts, the ventral portion and the dorsal portion. We know ventral is anterior portion and posterior portion. Is it clear?
Right.
Okay. Is it clear? Yes or no?
Yes.
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 Okay.
No.
No. Okay. This is your thalamus. Thalamus is going to be having this beautiful Y, which is going to divide it into three portions: the anterior portion, the medial portion, and the lateral portion. Is it clear? Hello?
Yes.
Yes. Yes.
Okay. If we just visualize this lateral portion, so the lateral portion is further going to be divided into two portions. Okay. That is going to be anterior portion and posterior portion. Is it clear?
Right.
Okay. That's going to be anterior portion and posterior portion. Is it clear?
Yeah, for this reason,
Okay.
it's called a VPL.
Wait, we are going to classify it a little bit more, right? Okay. Okay. So the lateral is going to be divided into anterior and posterior portion. Is it clear till now?
Yes.
Yes.
So we are going to
Yes.
take this anterior portion of the lateral portion anterior, and further we are going to divide it into three, right? Again, it's going to be ventro anterior portion, ventro intermediate portion, and ventro posterior portion, right?
Right.
Is it making any sense to you guys?
Yes.
Okay. Okay. Then we are going to take this ventro-posterior portion, and further we are going to divide it into two portions: the medial one and the lateral one. Okay. So the lateral here is having a nucleus, which is called as ventro-posterolateral nucleus. Does that make sense?
Yes. Yes.
So you guys might be hearing a lot about VPL, VPL. What is VPL? So this is your VPL. It's basically present in the ventro posterolateral, distribution of your thalamus. Is it clear?
Yes.
Okay. Okay.
Yes.
So as we discussed, these fibers are going to move into the VPL, and from the VPL, it's going to move into the internal capsule. We are going to discuss internal capsule is basically compacted form of all of these fibers. So the fibers which are going to move into the central nervous system and back from the central nervous system into the down into the spinal cord are going to be moving through this internal capsule. So these are compacted form of your fibers, either moving up or either moving down. Right? Is it clear? So this was the entire pathway of dorsal column and medial lemniscal system. Right? Okay, so the time is over for today's session. Hope so you guys enjoyed, and we have a lot of new students. And as we are starting our marathon soon, we are gonna drop text in the groups. Those who want to join it, today was the first day for the new sessions. They can just reach us out. Thank you so much. Thank you, and see you tomorrow. Yes, we are gonna share the recording in every group as soon as possible. Thank you.
Thank you, doctor.
Thank you.
Hello? 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 Is class finished? Hello?
Yes.
Class is finished?
Yes.
Okay, thank you.
Yes. Hmm. Okay.
Is there any problem in the lecture?